What's up, guys? Alright, a little bit of a later start today. Today's the 5th. I had to some other stuff, which is, you know, life. Always some other shit you gotta do. So we're starting at 11:10. I was actually ready for like 10:30, but you know. So we stopped at line 317 in server refactor. Implementation of apply order integrity issue regarding of finish implementation of apply order integrity issue regarding completion of changed attribute list .py logic. That's terribly worded, but it's fine. Double checked, everything looked good. So we finished change attribute list file. So now we're moving on to the next one. So let's go to server refactor line 317. Alright, so yep, that's where we stopped. And we're picking up okay, so we need to implement the expect counter in client and server. Okay, so that would be this file, or what we do anyway. So let me just look at, yeah, so yesterday we did the for function. Yeah, we finished all this stuff with this with the apply counter. Okay, yeah, so now we have to make it so that the apply counter, we already took care of apply counter is added to the attribute list. So now we have to add logic for receiving. Okay. Yeah, so first we'll implement the expect. Actually, we'll do the expect counter after, because I'm not exactly sure how that's gonna end up working. Like, so let's talk about the expect counter for a second. So the expect counter is the value that the receiving side is going to let's go to things to do. Let's do this in here. Modifier server refactor. Okay, I think first what we need to do is we need to consider, yeah, we took care of this, do not send junk data. Okay, we took, well, we'll do that. I'll leave this little note for now. I can get rid of that. Okay. Yeah, so we need to finish replacing the all logic which checks timestamps for data application with counter logic. Consider logic for counter concerning, and this is really like separate different things here.
Sam, I can't sleep at night sometimes. That's why I don't want to listen to the news late night. How do we handle that? How do we handle that?
Well, see, when people ask me questions like that, my answer is think for yourself.
Okay.
Figure it out yourself. Think for yourself.
Okay.
Figure it out yourself.
Okay, and then we have, so we have ensure that we do not apply, finish replacing all logic with check timestamp. Okay. Consider logic for counter concerning whenever sending from client side. Okay, yeah, so this is what I wanted to think about. So we have the counter on the, we currently made two counters, and it's C1 and C2, and they stem from the change attribute list file, and they're attached to the data transfer function. So whenever we modify from the server side, that's the ones that we use. Now, whenever we're operating from the client though, and we do make changes from the client, so that means we're gonna need to, well, we can let me think about this. So if we're importing the C1 C2 counter on the client side from the, to the client, for the client it's going to start at 0, and it's only going to increment every time we make a data change on the client side. I was worrying like, well, would it reference the server side? Obviously not, because those two things are separate. The server is disconnected from the client, even though they're connected on my machine for now. Like ultimately it'll be two different, 3 different machines, the server and 2 clients. So we are able to use the same C1 C2 counter on the server side and on the client side. Like we don't have to create another set of counters or whatever, because since the client is disconnected from the server imports the C1 apply counter, or rather handles the C1 apply counter via the data transfer function from this file, and the client does the same thing, and both of them are going to start at 0, and both of them are going to increment on either side as they make data changes. Okay, so then it would just be the same concept for using the expect counter, and we can add the expect counter. I mean, we could add the expect counters here. I mean, it makes sense, right, to just add them because they directly correspond to the apply counters. So we could make like we'll make a C1 expect counter and a C2 expect counter, just like the regular apply counter, and that's going to, like, let's talk from the server perspective. From the server perspective, there's the two counters, the expect counters. Each thread would handle its associated counter. If it's thread 1, it handles this. And whenever it is, it'll start at 0. So we'll say that because we increment first, right? We increment from 0 to 1 and then we send it. I'm pretty positive that's how we do it. Yeah, we append the C1, C2 apply counter after we, we add the C1, we add the apply counter values after we increment them. Spit it out, Josh. Just spit it out, man. Okay. So when the server side thread 1 is accessing the C1 expect counter, it's going to be expecting 1 as the apply counter value that comes through with the change attribute list tuple data change. And yeah, so it would just work both ways, the exact same. There's no conflict, I don't think. I was just working that out in my head, making sure there's not going to be any conflicting aspects of that, using the same counters, because like we said, the data changes, and we did look through all those, right, all the way, to make sure that only the main thread does. Yeah, see, so we did this. I remember going through this. All this is gonna be main thread or client side, or rather, not main thread. But when it's not main thread, it's not actually gonna run the data transfer function. We already talked about that because of change from dirt check and all that. So let me just triple check just to make sure real quick, because I'm not 100%. Okay, now this one. So I'm checking to make sure that they're all handled only through the main thread. Yeah, so server side, thread 1 and thread 2, I mean, client thread 1, client thread 2 would not handle this. This is handled through the event handler, and the client threads don't they don't run the they don't do draw window main, which is where the event handler comes from. Isn't that right? I mean, I'm almost certain of that. Like, definitely. Well, they shouldn't anyway. Let's check the client real quick. And let's look for draw window main. I'm certain that this. Well, wrong file. I'm an idiot. Server actually. Because we're the client thread, not actual client. Yeah, and I actually had it, but I commented out. I don't think we're supposed to call draw domain server side. It should disappear. Yeah, we shouldn't. Like, we don't. Yeah. Because it's server side. Like, we don't draw the window at all. Which, you know. I'm pretty sure, like, yeah, we definitely don't need to do that. It has worked thus far. So we're gonna go ahead and get rid of that. I'm 1000% certain that we're not supposed to have that. Okay. Okay, so now we know. Yeah, that is not done. Oh, there's something wrong with my new. It's the new hard drive. That's the one. That is the problem. Okay. I'll have to mess with that later. Right. My hands. Oh. So that's the thing that keeps. It was cheap. It was cheap, boys. Buy cheap shit. But when you're poor, that's the way it is, right? Anyway. Okay, so we don't handle that section of code, which is, let's go back to our Control-Shift-Tab, called the search, like research, I don't know exactly what you call it. And we're down here in game. Yeah, so this is, that's an event handler. This one is, and that's only going to happen on the main thread or on the client side, but we're not worried about, like, we don't have to be concerned about multi-threading on client side. Obviously client side is just one thread. So yeah, all this stuff that's in event handler we don't have to worry about. Type checking is off. What is type checking exactly? It's so slow, man. Type checking. Type checking pattern refers to the process of verifying the type of data of variables in a program. It ensures that the data being operated on is of the expected type, which can help prevent errors and improve code reliability. Python is dynamically typed, meaning you don't have to declare the type of a variable when you create one. but it still allows for type checking. There's several ways to perform type checking in Python. Using the type function, the type function returns type, okay. Using isInstance if an object is an instance of a particular class or type of any of its subclasses, for example. Using annotations in third-party libraries, Python supports type annotation, which allows you to specify the expected types of variables, function arguments, and return values. Libraries like modpy can then be used to perform static type checking. Name string returns a string. Return hello plus name. Print greet Alice. Greet 5 error. Okay. Okay, I see. So then if you try to pass in, well, that would already have happened, like without you doing that. You already would have got it. Well, I don't know. I don't know if you can actually add integers and strings together. Type checking helps in catching errors early in the development process, makes the code easier to understand, and facilitates collaboration in larger projects. However, in Python, it is also important to maintain a balance between strict type enforcement and the language's flexibility and dynamic nature. Okay. You cannot directly add an integer or a string. Yeah, so that would have thrown an error either way. Alright, so we're so that's the one we're on. Yeah, and that's not to be worried about. It's in event handler. So draw card setter. And that one's safe because of the logic we added. And now progression, this is only going to be run from the main thread, so we're safe there. We're safe here, and that's it. So yeah, we're safe. We're verify that, and let me just add this to notes so I don't forget about it. I seem to have a problem. And what exactly is it that, okay, yeah, we verified thread safety for apply the C1, C2 apply counter. Yeah. So, done. Cool. Oh yeah, so we're adding in the so we verified that about the thread safety. So now we can go ahead and just add the actual C1, whatchamacallit, C1 expect counter. equals 0, and then we'll have the C2 expect counter, and this will have its own little div. Oh, I can't type at all, man. A counter that's incremented by +1 every time a data point change is applied. So yeah, well, I guess we'll start them at 1 because they're gonna be expecting the apply counter to have already been incremented to 1 since we start at 1. Well, since these start at 0, they get incremented to 1, then they get added. So the first data to come over will be a value of 1, so that's what you should start with, expecting. And then after we receive it or apply it, we will we'll increment it after we apply this data. The counter that's incremented +1 every time data point is applied. What else do we need to write here? A counter that's incremented by +1 every time a data point change is applied is used to ensure that we are applying only the next data point change, not applying data out of order. Alright, and it's used in client and server pie to ensure we are, yep. Okay, yeah, so now we have that. And what we'll do is we'll import the C1, C2 expect counter to both of the files. We'll start off with server refactor. Let's go up here and we're gonna from changes tree list import all this stuff and also the C2 expect counter. Okay. And then we'll go to client refactor and we'll add that in as well. Okay. Okay, so I implemented the expect counter in client and server. So now we need to add logic for receiving and applying data in terms of apply counter instead of timestamp. So now we're going to replace all this code that takes care of the application process. So let's go there, which is going to be in our receive section. So let's open up this one. And we can close that. We collapse that. We don't need to see that. We're just going to receive data. If type receive data is equal to tuple, receive data is changed to list. So this is, we added this if else for whenever we're doing receive verify, and we're not done with receive verify system. So like I'm not gonna mess with that. I'll just leave that logic as it is, and I'll just basically replace what I have to. If it has to be further refactored later on, that's no big deal. Okay. So let's just go line by line here and see what needs to be changed. So if received data timestamp. Okay, so we changed the name of received data timestamp list, did we not? Let's see. Didn't we? I totally remember changing the name. Remember, well, if you were here, we did that. Maybe it was in this file, in client. No, received cal. Oh no, yeah, there it is. Received change attribute list tube list. Yeah, so it was in client refactor that we changed this. Did I log this? I didn't log it in devlog. I don't know. I can't remember which one exactly this replaced. Did it replace change attribute list? Not change attribute list. Inc timestamp list. I'm guessing it replaced this, the received data timestamp list. Yeah, received data timestamp list, received change attribute list, tuple list. To store the timestamps associated with each receive. And this is a compilation list of all received change attribute lists. Okay, so this is a compilation list of all received change attribute lists. It's structured exactly the same as current client change attribute list, except we add as a final element the received data ID for later dir check arg assignment. Consists of tuples, timestamp dir string attr name, for the purpose of storing received data. Timestamp float info, then be ordered from earliest, then be used to apply data via received dir check calls based on this order. Is depopulated as the associated timestamps data has been applied. So let me search for it in this file and see exactly. Okay, so now I'll know what it replaced based on looking at this step by step. Oh, but these are different now. I updated one after the other. But we might be able to figure this out. Depopulate. Just iterate through the data change attribute list. During iteration, okay. Append each entry to the received cal tube list. Mirroring entries exactly, but adding a front of the element to key the content. Yeah, all that needs to be updated. So that's not even true. So I'll just go off of the actual code. Is that? Oh no, I was looking at the receive side. I'm an idiot. Here we go. So it is the same. Iterate through the received change attribute list, appending each entry to the received cal tube list. So that's step 6. Iterate through the received changed attribute list. Okay, so that the received cal tube list replace the received change attribute list. Sort the received cow tube list. So it's just a list of all tuples that are received. So when we receive the changed attribute list, we then extract all the data from it, appending each value to the received change attribute list tuple list. Yeah. And then we will sort it based on which was the timestamp, but now is going to be the counter. So that comment for the received cow tube list, is that not incorrect? It says is a compilation list. So this was, I didn't change the comment. Is a compilation list of all received change attribute lists. It is structured exactly the same as change attribute list, except as a final element the received data ID. Okay, yeah, this is just not correctly worded. We'll put created 6/5/24 type is a list used. Is a compilation list all received change attribute lists tuple entries. That's more specific. It's a compilation list of all received change attribute lists tuple entries. It is structured exactly the same as the change attribute list, except we add as a final element to each tuple. Yeah, so let's see. Receive data ID equals receive data 0. Okay. And then here we go. So then instead of doing current client received, which one are we replacing? Current client receive cow tube list append tube 0, tube 1, tube 2, tube 3, tube 4, then C1 apply counter, tube 5, C2 apply counter, and then received data ID. So that gets appended. That's yeah, received data ID becomes part of each tuple, which the tuple is the element, each element in the received cow tube list. Okay. But is that correct? Do we actually, like, do we still do that? Use the received data ID, like, do we actually use that received data ID? So yeah, we just use the received data ID. I'm trying to think, like, why exactly we're using the received data ID. Other than to like assign this right here, do we actually use it in the way that we're saying that we use it? Client receive code to implicit pin. Okay, I see that we added here. We added there. Okay. This is tube 0, tube 1, tube 0, tube 1, tube 2, tube 3, tube 4. So tube 4 is received data ID. So it says if tube 4 is equal to current client ID, current other string. So it is used to assign the right because, okay, I remember now, we need it because the apply list is like completely separate as far as the code block. Doesn't happen in the same iteration, so the received ID, data ID does get assigned way earlier, but we still have to pass it into that tuple because that block that generates the received data ID is a completely different like block, and the received data ID will be like that received data ID would not be usable. It wouldn't accurately reflect each received data ID for each tuple. Okay, so that is true. I just want to make sure the comment was correct because, yeah, you want your comments to be right too. We don't want to have ugly comments that are wrong. This compilation is the following. Structured X statement. So we has final element to each tuple receive data ID for later dirt check arg assignment. Yeah, that's true. Not like directly, but it is indirectly true. Ultimately, consists of tuples, timestamp, dirt string, adder name. So storing, receive, data, timestamp, float info. So this is not going to be float info now. This is going to be this will be apply counter, which will then be ordered from based on that counter from least to greatest. And will then be used to apply data via receive dir check calls based on this order. It's depopulated as the associated timestamps data as the associated counters data has been applied. Okay, so now that's a more accurate comment. Okay. So what should we do next? We can bring server refactor back over here. Well, actually, okay, so it replaces the received change attribute list. So let's bring this over here, and we're going to be working there. So let's close out client. I don't want to. Well, actually, we'll copy this receive cal tuple list, and we'll bring this over to, which is received data timestamp list. That's the one it replaces, right? Because if we do a search on it, it should show up. Yeah, it replaces the received change attribute list. I don't think that's right, actually. I don't think that's right. I'm just gonna not worry about client refactor right now. I'm just gonna go through this and we'll just go line through line and just completely redo it. Forget that, because I'm just like confused. I don't think that's right, and it's just a few like little things I can change on client refactor. I'd rather not copy from there and just start fresh on this file. Okay, so we're starting fresh here. Forget that concern we had about the list we were just looking at. So we have the while true start receive section. If ready, if true, we don't want to read the step by step. Now we have if type of received data is equal to tuple sub.received data timestamp list append time by time. Received data ID equals received data 0. Okay. Received change attribute list. Alright, so that actually, yeah, we don't want to change that. We want the received change attribute list to stay the same. Now, received data ID is equal to current. Okay. Alright, that's fine. That stays how it is. Retrieve and receive change list. Okay. Timestamp list. Okay, so this is the one we actually want to replace. We want to replace the ink timestamp list. So the ink timestamp list is going to be changed. We're going to change the, let's put this right here, ink timestamp list being replaced with the better name of what? Well, I think that's the one we actually should have applied it to. I think we maybe made a mistake here. The receive cal tuple list. Yeah, it's the received change attribute list tuple list. It's a list of all the change attribute list tuples. And that's what this is. We're iterating through the received change attribute list, and we're appending all we're appending all of the tuples to what was called the ink timestamp list. Yeah, and the better name for it would be the received change attribute list to list. Received cal tube list, and that's what we named it here. If I, or here. Yep, received cal tube list. So now, okay, yeah, so we can copy this. That is correct, the comment and the name anyway. But I don't know if we like replace the correct thing in the file. It's okay, we can fix it. So we're gonna change this to be, whoops. We'll go up here and we're gonna replace the ink timestamp list. Right, okay, here we go, yeah. This is the same comment, as you can see, is a compilation list of all received. Yeah, so that's the one we meant to replace. Maybe I did. Either way, it's no big deal. Alright. So now we need to replace all instances of ink timestamp list with the received tube list. And this is now going to be from the lowest, instead of earliest timestamp, it's going to be sorted from lowest apply counter to highest, using sort with basic lambda function based on apply counter from tuple. Okay, and that is correct. So sort the received cal tuple list from lowest apply counter to highest. Okay, that's right. And then depopulate the received cal tuple list as the data is applied. Okay. Now this is the comment appends each entry of the received attribute list to the ink timestamp list in the form of timestamp, dir string, adder name, data, received data ID. But this is not actually complete anymore. Now we have the more in the tuple, so it's gonna be like this. This is how it's appended to the change attribute list, and that's the one that we receive, and we're iterating through it right here on this side. So it's going to consist of this. Yeah, the list elements of the received change attribute list at this point is going to be timestamp, dir string, adder name, adder name, data, apply counter 1, apply counter 2, and then we're going to append each entry to the, yeah, so this is going to be replaced, but we're going to add the received data ID. What was it? The received data or receive data? Received data ID. Okay. Alright. dirt string added names here. That tuple got a little bit long. We need the ID to assign current or other string later on for dirt check arg assignment. Yeah, that's fine. So ink times that list, yeah, we're doing that now. So now we're just going to continue to do this search and replace. Alright, so now we're going to say self.ink timestamp list. We're going to change this to receive cal tuple list. We're going to append tube 0, tube 1, tube 2, tube 3, but it's actually going to, now it's going to be 0, 1, 2, 3, 4, then 5. So tube 4 and then tube 5. There we go. And then the receive data ID. Okay, so now I can replace this without having to worry. Alright, so now it's going to sorts the ink timestamp list using sort with key param equal to a custom lambda function which sorts based on the, and this is now going to be the apply value for that sort outputs in ascending order I. Okay. So this is, and I can just see like that, it's faster. So we're not going to sort by tube 0 anymore because that's the timestamp. We're going to sort by 0, 1, 2, 3, 4, 5. Or okay, this actually we have to determine this. Isn't that correct? And it's actually break time, and we'll go our little 15 more seconds though. 2.5 has to be determined based on ID of received data. So receive cal to sort. So we have to put this, we can just say if receive data ID, actually since we do that up here, we already do it for receive data ID is equal to current client, right? So we don't do it in terms of 1 or 2 though, so we actually have to redo it because we have to do it in terms of 1 or 2, not just current client, because current client ID could be 1 or 2. So yeah, we'll have to say if received data ID is equal to 1, then we'll say tube index equals, it would be 0, 1, 2, 3, 4, and then elif received data ID is equal to 2, and the tube index is going to be equal to 5, right? 0, 1, 2, 3, 4, 5, yeah. Let's put a little div here. Oops. Whoa! And then we'll do our little section 24. Uses the received data ID to determine the tube index for determination of which apply counter to use. Uses C1 apply counter, and then this one will use C2 apply counter. And I'm pretty sure that's right. 0, 1, 2, 3, 4, 5. So we should, if ID is equal to 1, 2 next is equal to 4, percent data ID is equal to 2, 2 next equal to 5. And then we will, oh, I like that. I like it being divided like this. So then we'll put the tube as the tube index rather as tube index. So after we iterate through the received change attribute list, we append each tuple to the received cal tuple list, and then we determine the tube index based on the received data ID so that we know which apply counter to use. Now, let me just think about this for a second. I'm going to take a break real quick. Make sure this is correct concerning counter logic. So that's what I'll do when I come back. I'm going to take a little break and we'll figure out the rest. Alright.